Function composition is a way of combining two functions that's not using one of our basic operations. Now remember, when you have a set of two functions, you can add them together, you can subtract them, you can multiply them and divide them, like any of your regular arithmetic operations. Function composition is something that doesn't really have an analog in an arithmetic sense, and this is what it is. So, first of all, the notation, you can write it as f with an open circle there. So that means f composed with g, f of g of x. What that means is you take g of x and you put it inside of f. So if I had two functions, f of x equals 1 over x, and g of x equals 3 plus x, and I want to do f of g of x, what that means is I take g of x, my entire function, and I plug that in anywhere there's an x in f. So basically, I'm taking this x and instead turning it into my entire function over here. So in this case, I would get 1 over 3 plus x. And that's my function composition. So keep in mind the order is always the second one is what's going in the first one, the outer function. Now, function composition has a lot of little caveats to it, because let's think about something like this. F of x equals 1 over x squared. G of x equals the square root of x. And what I'm going to refer to here is the domain and range. So let's think about what f of g of x would equal here. Well, I'm taking g of x, square root of x, and I'm plugging it into f. So this would look like 1 over, and instead of x, I'm putting square root of x. I still have to square it. Square root of x squared is just 1 over x. Here's the problem. The domain of 1 over x is all numbers except 0, all real numbers except 0. That is actually an incorrect answer for the domain of this composition. Whenever you do a function composition and you're asked for the domain, you have to do it before you simplify and after you plug in. So we need to look at this step right here to look for our domain. The reason being is we have something square root of x for g. We can't plug in negative numbers. The way you can think about that is, if I had a negative number for x, I couldn't have even got an answer to plug into f in the first place, even though it seems to simplify to this. So basically, I'm looking here and saying, oh, I need x to be greater than or equal to 0. And now in your final answer, you see, oh, x also can't be 0. So I would take away that or equal to, and you would say, this is only from 0 to infinity. You don't include the negative side because you couldn't have had it before you simplified either. So that's the implications of function composition with regards to domain. But the actual algebra of it is relatively simple. You take your function, you plug it in for x.